My name is Nicola, aka Socrates, and you're watching Singularity One-on-One. Singularity One-on-One is a feature of Singularity Weblog, and if you want to support the show, you can do so by writing a review on iTunes, leaving a comment on YouTube, or simply by making a donation. Today, my guest on the show will be Grady Booch. Grady is an IBM fellow, a software engineer, a geek, a philosopher, and a storyteller. So, welcome to Singularity One-on-One, Grady.
Thank you for having me here.
Fantastic. So, let me ask you to perhaps elaborate or introduce yourself in a few words to begin with, for those of our viewers who may not be familiar with you and your work.
Wow, that's a great question. Professionally, I'm very passionate about software-intensive systems and the ways that we build them and the implications for such systems on humanity. It is that set of things that drives me professionally, and I'll break that into two parts. On the one hand, through my professional career, I've always been interested in a meta issue. How is it organizations build successful software-intensive systems, and what is the structure of these things? That's what's led a lot of my methodological work, and it's also led the work I've done in software architecture. On the other side of it, really, this is something that's evolved over the last 7 to 10 years. Having had the opportunity to interact with projects in really every conceivable domain, I've been really truly graced with the opportunity to work with projects from everywhere from web-centric systems, from companies whose names are very familiar and spend several $billion acquiring companies, like one that just happened that I won't mention the name of, all the way to hard real-time systems upon which human lives depend. The vast spectrum of things is something I've been exposed to, that it's a very rare thing, and I'm very appreciative for it. But in so doing, I think I learned a lot about the landscape of software-intensive systems from that perspective. And that's what prompted my curiosity in the area of design patterns, in the area of architectural style, architectural description, that's fueled a lot of what I do. And those two go hand in hand, because organizational architecture and software architecture are wonderfully messy, dynamic things, and I like to put myself in the midst of the mess of that. The other piece of it is the growing observation that the systems we are doing are no longer part of a zero-sum game. We inject these systems into the world, and they impact the world in ways that are unforeseen. So I began this riff some years ago on the notion of the moral and ethical implications of software engineering. And people looked at me and said, "You're nuts. There are no moral and social implications of software engineering. It's a technical problem." And I kept beating the drum, saying, no, there are human applications to it. That led me to, which I'm sure we'll talk about it in more detail, my current project that keeps me consumed, and that's a documentary my wife and I are developing in conjunction with the Computer History Museum, Computing the Human Experience. So it's those two pieces of my professional life that keep me busy.
Mm-hmm. Now, I have to share with you that the moral implications, the ethics, and the implications of technology were the core reason why I started this show to begin with. And let me throw a little bit of a challenge that I'm facing from one of my good friends of mine here. Now, on your, I think it's your Twitter profile, you say that you are an IBM fellow, a software engineer, a geek, a philosopher, and a storyteller.
Yes.
Now, so I have this engineering friend of mine who likes to point often to me that philosophers are all bullshitters. Because engineers, you see, they produce something worthwhile, something tangible, something that you can touch, see, and smell, like a bridge, and everybody uses. Whereas philosophers are all just making those pies in the sky, those castles in the clouds, and bullshit all day long, and in the end of that day, there's nothing to show for it. You, on the other hand, are one of those strange birds that seems to be both a software engineer and a philosopher. So tell me a little bit about how that works out and what's the interplay between those two.
I'll answer that question by telling you the handful of people that have most influenced me from a thinking perspective. And I'll throw out the names and explain to you why. And it's a very curious set. First, we have Richard Feynman, the physicist. I would also put in this category Joseph Campbell, the mythologist. I would add Carl Sagan, and lastly, Herbert Simon. Now that's an interesting mixture because you've got in that group of folks a set of people whose values and view of the world I relate to greatly, and so that's why you see I view myself as both an engineer and as a philosopher. On the one hand, you've got people like Herbert Simon. His book that influenced me the most is The Sciences of the Artificial. And as it turns out, Herbert's work in that area was a profound influence for me upon the development of the UML, because Herbert was observing that all complex systems, be they organic, be they human created, be they things we see in the natural universe, all have a common set of characteristics. And it's those characteristics, these design patterns of the universe, if you will, that influence my thinking of architecture. By the way, Herbert was a very pragmatic engineer. He's one of the people who built the very first theories of systems for artificial intelligence and really honestly built things. You've got then Richard Feynman, also a very pragmatic engineer, but also a philosopher, a brilliant physicist, but also a brilliant storyteller. And you can think back to the work he did with the Manhattan Project as a manifestation of some of the very concrete things he did. But now we start turning our attention to more of the storytellers and the mythologists. That's Joseph Campbell. What I adore about Joseph in his work is his realization that we as a society build these wonderful things, but we also have this need inside ourselves to understand ourselves. And it is from that that our mythologies were born. And lastly, there's Carl Sagan. And I'll end with a quote from him that I'm going to adapt. He uses this phrase that says, I'm gonna get it a little bit wrong here, but to paraphrase him, we live in a world that is exquisitely dependent upon science and technology, and yet most of the world does not understand science and technology. I'm going to reframe it. We increasingly live in a world that relies exquisitely upon computing, and yet most of the world does not understand computing. You talk to the average millennial or the average tween, they'll look at their smartphone and they'll say, wow, this is cool. I can look at this. I can, maybe do a web page. I can, use Facebook, but I have no great curiosity for what happens below the surface. And we're building civilizations dependent upon that. It's my personal drive to open the curtain on that technology as an insider. Having built these things and having helped people build a lot of these things, I feel it's now the time to rip open that curtain, just as Sagan said, because we so exquisitely depend upon it. So that explains to a degree, I hope, why I am sort of in the middle. I do have a philosophic bent, but I also like to build things as well. I still program these days.
Mm-hmm. And I mean, I enjoyed very much one of your presentations. I mean, many of your presentations, but in one particular one, you told a joke about how much does software weigh.
Oh.
And
Yeah.
that kind of leads me to point out that, you're one of those engineers, namely software engineers, who don't have a tangible product in the end of the day, perhaps, or at least not always, because, as we know, the software is in the holes.
Yes, the software is in the holes. Absolutely.
Right.
Yeah, a lot of the tangible, I manage several websites of my own for the research work that we're doing. And so, pretty much every week I'm doing some degree of Java and PHP, which is fun, but it's certainly not, high scale volume internet at scale stuff, but that I do. It's also the case that, and this is, I'm sure we'll talk about this in more detail, in the last couple of years, my bent has been moving toward cognitive systems, which has put me into the guts of things like Watson. And I've had the opportunity to work with that team, and now continuing on with research to what do we build on top of Watson. So I'm starting to code there as well, which is fun.
I have previously interviewed David Ferrucci, who of course was the team leader behind Watson. But before we go to that, let me grab the lifting the curtain on computing idea. Is that basically the purpose of creating your documentary that you're telling us about? And how far along that project have you come so far?
Sure. Thank you for asking. Let me set the context for your readers. I'm on the board of trustees for the Computer History Museum. Len Shustic invited, and John wasn't there about that time, invited me to join the board because by then, this was about 5, 6, 7 years ago, they were heavily loaded toward a lot of hardware folks on it. You had any number of luminaries, but they needed some software geeks. So Len came to me and said, would you join us? Because my passion then was one of software archaeology, and I had done a number of studies to find classic bits of software to preserve for future generations. By the way, as an aside, the museum has been able to preserve the original source code to Mac Paint. I think they've gotten the original source code to DOS and the original Word. So these things are being preserved for future generations thanks to the work of the museum. Anyway, John Huller and I were having a conversation one day. John had just landed, several $1 million from the Gates Foundation, which helped push them over the edge to do the current exhibits. And I was, teasing with him. Having known that John had been at PBS, I laughingly said, hey, John, thanks for the $10 million. What are you going to do for me today? Kind of question. So when are you going to do something like Sagan's Cosmos? And he paused and said, Grady, why don't you do that? Well, I then paused and said, well, I'm no Carl, but that's an intriguing idea. And it led me down the path to say, this might be something that would be very interesting to do. Why would I want to do this? We have a whole generation that is growing up with this technology, and there's some really cool shit behind it. I wanted to open up the curtain and express to them my delight and joy and just awe that I see when I stare at a complex system. Just as Sagan can say, let's look at this, constellation and look at this galaxy and be awed by it, I similarly look at a complex software-intensive system and say, my gosh, this gives chills inside me, and I wanted to share that same kind of thing. At the same time, thanks to my wife, who is by education a psychotherapist and a theologian, she observed to me that, Grady, all this technology stuff is great, but let's not forget the humans. And so thus was born our fundamental concept. Let's not look at this from just the technology perspective, but let's look at the problem at the intersection of computing and humanity, and thus was born the idea. So we're on a path, we've been on it for 5 years now to develop this documentary. The Computer History Museum is very supportive of what we're doing, and we're right now in the process of dancing around with a director / producer to move on to the next level. Last year, we went with KQED, the PBS station in the Bay Area. We developed a teaser, some treatments, and we went to corporate PBS and pitched it to them. Corporate PBS was very excited about it. So we're on to the next stage of that development. But believe me, Hollywood is a very different place than Silicon Valley. It truly is.
And when do we hope to see that available, say, on PBS channel?
Before I die is the answer I give.
Well,
I don't have a Seth MacFarlane.
I was hoping it would be sooner than that.
I'm sure it will be. I don't have a Seth MacFarlane in my pocket. Seth and Neil deGrasse Tyson happened to get together at a scientific entertainment meeting, and they were just chatting. And basically Neil pitched it to Seth, and Seth said yes. But of course, Seth is a multimillionaire whom Fox owes lots of money. So that's how the Cosmos reboot was done. We don't have any such folks in the computing space, but hey, I'm looking. So if any of your viewers out there are inspired to help me do a documentary, let me know. We'd be more than happy to help.
Well, I would actually second that call. and say that I have some really incredible. I mean, pretty much most of the people, if not all of the people watching this, all of the people watching it on a regular basis, this show are incredible. So you never know what's going to come out of the rabbit hole.
You never know. One last thing for your readers, shameless plug, it's computingthehumanexperience.com is where you've got all our stuff. One of the things we've done along the way, too, is provide a series of lectures. We've covered some, topics that the average computer scientist would not cover. And by the way, I stole that title from Don Knuth. He's got a great book, Things a Computer Scientist Rarely Talks About. So we looked at the obvious ones of computing and war, but my most recent one that we did was computing and faith. And who would have thought those fit together? But turns out they do. Go watch the video.
Yeah, I've seen them both, actually, and I can again testify in support. I myself, by the way, started as a political science student with heavy emphasis on just war theory and armed conflict.
Wow.
And then I wrote a thesis on artificial intelligence in times of war, which was around 2006, 2007, dealing with the first drone attacks in, Afghanistan, first Iraq, then eventually Afghanistan. And the sort of the exponentially growing armory of drones employed by the United States government and nowadays by other governments too.
Man, you and I need to sit down and talk more because that resonates with me greatly. I don't know if your listeners realized in my pre-long hair days, I was a graduate of the U.S. Air Force Academy and I was in the Air Force. So I was on the other side of things where I was building systems like that. I mostly worked in the space program. So I hear what you're talking about. Absolutely.
Were you building them or were you a pilot also?
I was not a pilot. My eyesight was never good enough. My best man at my wedding, my dear friend Tony Grady, he wasn't just a pilot. He was an Uber pilot. He's a guy that flew SR-71s. I had another roommate.
Wow.
Yeah, that's a serious plane.
That's the Blackbird, right?
That's the Blackbird. Yep.
Wow.
Tony was interesting. I love chatting with you. He has this great story. We talked about the software-intensive nature of an SR-71. He said to me, Grady, the SR-71 is alive. It really is. I also have some other classmates. We had an amazing class of 77 who are astronauts. Another classmate by the name of Tom Jones, he actually assembled most of the International Space Station. For me, I worked on ground support for intercontinental ballistic missiles and the military shuttle program, which nobody knew about then.
Yeah, I was strategic nuclear communications when I was recruited in Bulgaria. That was sort of a couple of years after the end of the Cold War, and they still haven't had the time to shift because, like, administrations such as the military take a very long time to sort of change focus and shift directions. So there's 5 or 10 years after the Cold War that we were still being sort of trained and brought up as if it was still going on.
Militaries and governments are not what we would consider agile organizations.
Yeah, that's true. Let's get back on topic though, and let me ask you to tell us a little bit more about sort of your contemporary responsibilities in IBM and perhaps your participation and role for the sort of the applications of Watson.
Sure. It's another one of these accidental things that drew me into this, given my interest in architecture. You mentioned David Ferrucci. A few years ago, would have been 2011, David was scheduled to give a keynote at a conference on Watson because we had just done Jeopardy. He was in great demand for it. But then at sort of the last minute, a couple of months before that event, David said, I can't do it. I'm double booked. Can you find somebody else? And they turned to me and said, Grady, would you do this? It was a developers conference. So I looked at the slides David was going to use and I said, well, these are interesting, but they don't interest me because they don't get to the meat of it. So why don't I do something that would be interesting for the developers conference, which is let's present Watson's architecture. Nobody had documented it in any detail. It was all part of the tribal memory. So for a couple of months, David gave me access to the core Jeopardy team. I spent lots of time with their 2 main architects, which is a story unto itself of good practice. And I basically did an archaeological dig. And this is what I've done for customers a lot. I sit in, I know nothing about the domain or the code base, and I have a process that helps me unfold it. From that 2-month process, the Watson team was able to write up a 30-page architecture description. So they were able to document the architecture, which had some useful things to it. By the way, yes, I did use the UML and Philippe Grushin's 4+1 model view. It's just my part and parcel of my tools. And I began to understand what the Watson architecture was. And this was very, very cool. Fast forward then about a year later, when all of a sudden IBM realized, oh my gosh, we've got something here. It's not just what Jeopardy did for us, but there's a business we can build upon it. So last year I was tapped by John Kelly, Michael Karasik inside IBM to lead what's called our Global Technology Outlook. And I can talk about this now because we're going public on it. This is something that IBM does every year, which I think is a great thing. We basically stop and say, what's happening in the world and what's out there and what's coming and where should we go? So it's our outlook, but it's also part strategy. And I was commissioned with the task of go figure out what the research outlook should be on cognitive. Don't limit yourself. Well, Watson's a piece of it. And that led me to easily 60 projects that we had in research. I'd say 500 researchers in IBM were doing something in this space. Now, being a systems engineer, but not a cognitive scientist, the first thing I did was go off and talk to people smarter than I am and read books. You'll look behind me and you'll see that I am old school. My wife's a Kindle person. For me, you will get rid of my books when you tear them out of my cold, dead hands. So I immersed myself in probably, 30 or so of the classic textbooks in cognitive stuff and just, immersed myself in that space. And then I immersed myself in the space of what IBM was doing. And then with a team who was just awesome, we then, by the end of the year, said, this is what we think IBM should be doing. Well, the announcement that Jenny did in the January timeframe, we're basically betting the company on cognitive stuff. Now, to be clear, I am not responsible for all that happened because there's lots of business things, but I was in the midst of the technical discussions. But basically, IBM has made the decision, we're going to do $1 billion bet on this and bet our next generation. So as you might imagine, it's been a very tumultuous time and a good time for IBM. And so, yeah, I'm in the midst of that right now. We've stood up a research organization to do the research side of it. There is a commercial organization, and I have taken the role of I'm kind of spanning between the two of them.
Now, let me try and decipher or try and put words into your mouth here. You said we are putting a $1 billion bet of the company and trying to move into cognitive stuff. It sounds to me you're telling me that IBM is trying to develop artificial intelligence.
We don't like to use the term artificial
I know,
intelligence.
that's why I'm trying to put words into your mouth. But if you're telling me cognitive stuff, and it's a machine, not a human, wouldn't that be fitting properly the AI?
I think it would. The problem with AI is that it has such emotional baggage to it. So I think we've chosen a more graceful, less emotional word of cognitive. For me, and this is part of our work, we define cognitive as something, it is a system that learns, it's a system that provides insight. And if you think about it, AI is a much bigger thing. We view the space of cognitive we're worried about is not these autonomous systems, but rather systems that work in partnership with humans. So that narrows the AI problem. That being said, I will say that there's lots of interesting things we're doing that have nothing to do with the Watson architecture. Watson's a pipe and filter architecture built upon a thing called UEMA, very sexy, but we also have some really deep learning things going on in neural networks. We're building neural network chips. So you talked about programming. Last year, I took a little bit of time off with one of the teams to program my first non-von Neumann machine. Programming thousands of neurons is very different than programming a von Neumann machine, and it just is really bizarre to get your head around it. So I basically architected an instance of life, but not using von Neumann techniques. It was It's really bizarre. And so I've spent a little bit of a foray into the neural space. And now the interesting research challenge to us is most neural networks we see are, 3 levels, maybe 6 levels deep. What tools, what architectures, what design patterns you need to build a system out of neurons that have as many neurons as the human mind? We don't know. And that's one of the interesting research challenges ahead of us.
Mm-hmm. Now, let me try and ask you to elaborate a little bit on some of the sort of the cool apps of Watson that we can hope to develop, perhaps, in the sense that we already know that Watson has been applied and will be further sort of tweaked to diagnose cancer. We know that it's been applied to be basically a telephone operator or a customer service phone rep. We know that there have been let me put it this way. The military would certainly be also interested in applications like that, but of course, probably you wouldn't want to discuss that. What are the cool apps of Watson that you, other than those that I just mentioned, that you'd want to discuss or tell us about?
Being a storyteller, one of the ways that I looked at the outlook was to tell a story, and that's by looking at the day in the life of a person who might interact with a lot of these agents. So we've developed a number of scenarios that, and I'm not telling you anything proprietary or secret here, but we envision a world in which you have this consumerization of the enterprise, as one of us calls it, meaning that there are things that enterprises would have need for Watson, just sorting through vast amounts of information, and thus the healthcare side of things, the retail side of things, anything that deals with that mass amount of information. But you also have the human side of it, in that many of these businesses are now dealing with systems of engagement. And so you're on this funny cusp of, is it for the consumer? Is it for the enterprise? Is it a dessert topping? Is it a floor wax, to use the old Saturday Night Live commercial? It's both. And so we're having to deal with that edge, which is very interesting for IBM because we don't deal with the individual consumer, but we're sort of being morphed in that direction to a degree. So in this day of the life thing, we realized, I've got a Fitbit here. All of a sudden, we've got a big data problem for the individual. I, as a human, am awash in information, and boy, I could sure use some help in that space. So we're doing some exploration in the space of, personal, digital, human personal big data, if you will, and we think that Watson has a role to play there. So that's part of our exploration. So you think of those cool things. One example of it is, suppose I have a system that knows what's in my refrigerator. It knows my likes and dislikes of what I like to have. And one day I say, this is like the replicator on Star Trek, go make me something from my fridge. And imagine a cognitive system that could say, well, I know what you like. I know who your guests are that are coming. I know it's in the fridge. Well, I can whip this together. Here are some recipes. We built that, and we are demonstrating that right now, this recipe thing that's built on top of some Watson technology.
That's pretty cool.
Yeah.
But let me go back, because you mentioned the vast sort of data that we're all awash in, and I just can't help it. But of course, the biggest, deepest well of data that anyone or any organization deals with is the NSA.
I've heard that, yes.
And would you care to say anything about that in Watson?
Would I care to comment about the role of Watson in the NSA? I am confident that the NSA would be very interested in that technology.
We're confident about that too. But so what? I mean, then,
let me pivot the question by saying, obviously I can't say anything direct on that, but I can say that this is me speaking, not anybody at IBM or representing anybody living or dead. Personally, I am offended, bothered, befuddled, gobsmacked by the reach that the NSA has done. I believe it is fundamentally wrong, verging on the issues of not only unconstitutional, well, I think it is unconstitutional, but I would say on the edges of immoral and unethical. So that's my personal opinion. It is overreaching. There's this phrase I use, which says that there are some things in our vision for computing systems. There are some things that we may dream that we cannot do because the laws of physics prevent us. There are also some things that perhaps we should not do. And this degree of pervasive tracking, I believe we can do. We can even do it to a greater degree than the NSA can even envision. But it's something we should not do.
Mm-hmm.
So believe me, one last thing I'll say, I have been asked to get involved with certain projects over my career in which I have said, no, I believe it is morally repugnant. I won't do that.
Mm-hmm. And that's where the necessity for ethics and moral implications of technology come into play. And that's why I believe we must stop and ponder and consider those before we take action on a technological level, justifying it as a purely engineering exercise, because I think it's never merely an engineering exercise. There's always wider repercussions.
People should go back to the discussions that Oppenheimer and others had during the Manhattan Project. Classic textbook case where we can do some things that necessarily we shouldn't do those kinds of things. Absolutely.
Now, let me reshift our discussion here with, but still on the topic of being invited to get engaged in certain projects. Here's a sort of a question submitted by Column Chase, who says, is the IBM recruitment story true? It is very sweet. I don't know what he refers to that. Would you happen to know about how did you get recruited by IBM?
How did I get recruited?
Yes.
He meant my recruitment story.
Yes.
I wasn't recruited. I was borged by IBM. I was assimilated. So let's go back in time here. 1982, I left the Air Force, as did two of my colleagues, Mike Devlin and Paul Levy. They started up Rational. I joined them. Move forward to 2001, 2002. Rational Software had made almost $1 billion in revenue, which is a lot of money back around the turn of the millennium. We were perhaps the first tools-only company that was very close to $1 billion in revenue. We got kind of sucked down in the whole .com implosion. And so revenues were great, but we were ripe for being acquired. So both Microsoft and IBM were looking at us. And IBM won the bid, and so we were acquired. And by acquisition, that's how I joined IBM. And having been acquired, I think I was the first one they've done this to. They immediately made me a fellow, which I'm greatly honored to have done so. It gave me degrees of freedom to do what I do. But that's my IBM story. The parallel to it is when that acquisition was happening, I had a call from a gentleman you might have heard of, Bill Gates. And Bill said, Grady, come talk with me. And so I had a nice long conversation with him. I won't go into the details, but basically Bill offered me a really interesting job, and I said no to Bill. I'm not getting his Christmas cards anymore, so I'm very sad. But
it must be because you keep sort of boasting that you're a Mac rather than a PC. Probably that's why it didn't work out.
The phrase you heard me said, yes, I prefer to use real operating systems.
Yes, I've heard that many times. Yes, yes, indeed. Now, let me jump in here a little bit more into the meat of the matter and ask you this. Simple question. Is intelligence computable?
Yes. I believe that the mind is computable. Now, let's explain what I mean by that. I mean it in the sense of what Turing describes, that it is possible for us to build a Turing-compatible machine that can give us the same behavior as an intelligent human. Now, that point of view is predicated upon a fundamental theoretical premise, which is that the mind itself, there's no magic going on there. It is part of the material universe, and therefore it is understandable. Now, when you get to the edges, you get into some really interesting debates with people like, what's his name? Roger Penrose.
Stuart Hameroff and Roger Penrose.
Yeah, who believe that it's materialistic, it's reductionist, but there's something quantum happening. There's no evidence to suggest that's true.
There is.
However,
very recent development.
And I read that paper. So, and it reminded me of what we learned about the gecko, by the way, the little animal, because we discovered that its mechanism for how it hangs onto the side is actually due to some quantum effects. So I saw the paper you're referring to, but what's unknown to me is whether those quantum effects truly do manifest them in a macroscopic way, or that's one issue, or if they are even necessary for the kinds of consciousness we desire. I have another belief that consciousness is an illusion, and there's a whole set of literature around this notion, but it's a very pleasant illusion that I'm happy to participate in, but that illusion also does not rely upon quantum effects. The nice thing is, what you described is we can debate it, and there are some really wonderful, fascinating experiments we can run to see whether that's true or not. But nonetheless, I'm fundamentally of the belief that there is no magic, and we can understand it, and we can compute it to a degree.
Mm-hmm. I have to say that I personally agree with you, and I am of that belief myself. However, having interviewed Dr. Stuart Hameroff, and actually I'm planning to go to his consciousness conference, biannual conference that he organizes at the University of Arizona in April.
Yes.
Again this year. I have to say that, I do often doubt myself in that belief of mine. But like you, I'm pretty much materialist. I believe we're made of atoms, and I think that the intelligence is computable, and that's basically the path to artificial intelligence.
You should doubt yourself, as any good scientist should, and I think that's a healthy thing.
The problem that I'm having to face as a philosopher, as a moral philosopher afterwards, though, is that of determinism, free will, and computability. Right? So tell me about that. If the mind is computable, and if it's a physical system with, pretty much determined effect following the laws of the universe, where's the room for free will then?
Well, we can go back now to the discussions that Calvin had on the very same thing. But it's one that is territory that people have walked across. And I don't know where we'll land on that, because if I take it to its ultimate conclusion, you could say there is no free will. There is no meaning. And on days like that, I can become an utter nihilist and say, well, why do I even exist and why do I care? That being said, I know that I know that I can look at the world and I sense and see great beauty, and that's enough for me. This goes back to what Joseph Campbell said. There is no meaning to life. The meaning to life is, the purpose of life is to give it meaning for ourselves. And so I think what is happening is that we are living in a sufficiently complex system that we have this illusion of consciousness, the illusion of free will, and yet it is still a very pleasant illusion, because within that illusion we have a sufficiently complex system that we can build meaning and find joy and happiness. And for me, that's enough. Mm-hmm. I can be a happy machine.
So we're living in the world of illusions. In Zen Buddhism, they call it Maya, I think.
Yes, we are. I absolutely believe we are living in that Maya. Absolutely correct. Mm-hmm. But it's a pleasant one.
Yeah. Well, depending on your particular circumstances.
Well, yes. If I were a woman with a child in Afghanistan at the moment, I would think otherwise.
Yes.
But yes.
So let me ask you this then. I mean, just backtracking a little bit, maybe that explains why I'm so desperately attracted to Zen Buddhism in general. Despite the fact that I'm an atheist myself, I just love Zen Buddhism and everything related to it. But let me go back on the AI topic and ask you, are we making any progress? Because let me tell you my experience here that kind of really surprised me. But I interviewed both Dr. Noam Chomsky and Dr. Marvin Minsky for this show. And what surprised me is that both of them absolutely categorically denied that we're making any progress whatsoever, even though for very different reasons. But they interestingly both achieved the same conclusion. So what do you think? Are we making progress?
Progress in what topic?
Artificial
Progress.
intelligence.
Artificial intelligence. I understand. The challenge of being able to discern whether or not we're making progress, it's difficult because we're so in the midst of this. I will say, with regards to Marvin's work, I'm heavily influenced by his ideas of society of mind. And I will observe that we are making progress depending upon how you're measuring progress. We're making progress in the sense that we are now able to codify and automate things to a degree that we could only dream about a decade or so. So things like Watson Jeopardy, it exists now. And so is that progress? Yes, you can say that that's a degree of progress from the perspective of putting this in the world.
Both of them denied that Watson is any progress.
Interesting. See, I would characterize it as progress because the existence of Watson, it's not a system that understands, but it's given us understanding of the architectures that give us the illusion of understanding. We didn't know how to build a system at scale that could respond to issues of human puns and ambiguity. So we've made considerable progress in natural language understanding. On that regard, I would disagree with Dr. Minsky on that one.
And Dr. Chomsky, because since he's the linguist, let me give you the quote from him.
Sure.
I mean, Dr. Minsky's sort of argument, the gist of it at least, was that we're lacking still a sufficiently useful theory of mind, and we're kind of like shooting in the dark as if it were. But Dr. Noam Chomsky, who is a linguist, who should know a little bit more about that, first when IBM created Deep Blue, when Kasparov lost the chess game with him, or with it, I should say. Dr. Chomsky said that that's as impressive as if a bulldozer winning the Olympics in weightlifting. And his claim here is that it's just brute force. But more to the point, let me give you the quote that he said in my interview with him. And he said, "What's a program? A program is a theory. It's a theory written in an arcane, complex notation designed to be executed by the machine. What about the program, you ask? The same questions you ask about any other theory. Does it give insight and understanding? These theories don't. So what we're asking here is, can we design a theory of being smart?" And his conclusion or his claim is we're eons away from doing that.
I would love to find a forum where I could sit down with Dr. Chomsky, because on the one hand, he is, of course, the world's most brilliant linguist. I know nothing about linguists. At the same time, he knows nothing about software and the notion of what software systems are and what they can be. So I think we could have a very lively discussion. The absence of a theory does not mean that I can't build something real. And so I think we have a bit of a disconnect in the sense that he's lamenting that we don't have a theory. My view, which I've said a few times, I will let the philosophers work it out. I'm just going to go build interesting shit and see what happens. And that's what we're trying to do. We'll let them sort it out later. Because if anything, Watson has offered a theory, if you will, in the form of its architecture that is one way to approach the problem that from a black box perspective, Watson does something that if I hold a screen in front of it, you'd say, that's pretty cool. And even humans have a difficult time doing it. Once I open up the curtain on Watson, you could say, Minsky, I think he would call it, Chomsky would say, this architecture is Watson's theory. Well, yeah, I guess I could agree with that one. And so I could have a discussion with him as to what that theory is. It is a theory, but it is not the theory. And the fact that I have a theory means I'm making progress, because now I've discovered something that works, and I've also rejected other things that don't work, and that progresses it. We can then have a discussion about, are we eons away? Well, don't get me in the same room with Kurzweil, because we're going to have a real long discussion on that one. because I respect and appreciate Ray, but I think what he is projecting relative to the singularity is more so a reflection of his hopes and fears than it is anything in reality. That's
Recently, he
another
said
discussion.
that we can expect something like the computer or the software OS in the movie Her around 2029.
Yes, and my reaction to that is I believe 2029, assuming that I am using a hexadecimal numbering system, or hexadecimal numbering system. So that would be true if it's 2029 in hex.
Okay, but let's say that you built that AI that Noam Chomsky said it's eons away. Kurzweil says it's like 15 years away, and you say that it will be somewhere in between these two. How do we know that we've gotten there? Because the other bomb that Dr. Marvin Minsky threw in my interview with him was that he said, quote, "The Turing test is a joke." End of
Oh,
quote.
I agree with him. The Turing joke is an absolute joke, as is the Loebner Prize, as in anything like that. This becomes the other mind's problem. How do I go up to a congressman and convince myself that they're sentient? Believe me, there are some congressmen I could talk to. I would have severe doubts as to whether they were sentient or not. So even with humans that I have to believe the other minds, I would be hard pressed for such a test. So I don't think we know. There's a delightful book I have back here that explores that very topic. It's like pornography, however. As the Supreme Court judge once said, I can't define it, but I sure know it when I see it. And this is an interesting research problem for us to have as a community. I don't know what the right Turing test is. Is Jeopardy a good Turing test? No. Is the traditional imitation game a good Turing test? No. Is what things like Cleverbot doing, is that a Turing test? No. I am of the mind that Rodney Brooks has, that the only real intelligences we're going to have, the true intelligences, must be embodied in the world. And until such time as we see those kinds of AIs that sense and affect the world, we're never going to get to that degree of intelligence. So this is a grand challenge that I have even among humans. What is intelligence? And the answer I give you is, I don't know, but I'm still going to try to build stuff and we'll throw it against the wall and see if it fits. Mm-hmm. That's what science is all about.
But the question then comes is from other people, like, for example, the Machine Intelligence Research Institute. Mm-hmm. What if you build it and according to some people, that would be the end of the world? James Barrett recently published a book called Our Final Invention. I mean, so there's two kinds of groups, or let's say three kinds of groups. One group which says the singularity will never happen. Another group which says that singularity will happen and it will be most likely the best thing ever. And another group which says it's going to be the end of the world because the machines are going to take over. So whereabouts do you stand, or do you fit?
I stand with Rodney Brooks. The singularity is going to happen, but we'll never notice it because we'll be a part of it itself. He said we'll never notice the robots taking over because we ourselves will evolve into it. One of the assertions I have for the computing documentary we're doing is that humanity and computing are co-evolving. And as part of a co-evolutionary process, you never notice those incremental changes. I live on an island, and I'm very intimately connected to the land here. And I see, we speak in Hawaii of the notion of a kama aina, somebody who is a friend of the land, because on a daily basis, you see the shifting of the sands and the migration of the whales. And these are slow geologic processes. I think the same thing is true with us and computing, that we're slowly co-evolving with these kinds of things, and we'll never notice that singularity. Are we evolving into a new species? I don't think any species can ever know it that is doing so, but we're certainly still living along the way.
Mm-hmm. Grady, unfortunately, time is advancing here, so I'm going to have to ask you my last two questions.
Sure.
And the first one is, where can people find more about you and your work?
I'm sure the NSA knows everything, so go ask them. But you can also go to computingthehumanexperience.com. That's one word, and that will tell people about the current documentary stuff that we're doing. And that actually will lead you to all the other cognitive stuff I've got. We've got links to our Twitter feed and our YouTube pages and all good stuff like that.
Mm-hmm. And the last question that I want to ask you is this. We've been talking for over 45 minutes by now, and what is the most important thing that you would like our viewers and listeners to take away from this conversation with you today? The one single most important thing.
That's a great question. I'm pondering that for a moment. It depends upon the audience to which I'm speaking. I will direct this to the computer scientists in your crowd that are watching. And the one thing I would hope they would come away with is that we live in a magical world, and we as developers are responsible for creating that world. The one thing I want them to take away is enjoy the beauty of what you're doing, but also take responsibility and own responsibility for what you are doing, because you are changing the world. That's the thing I'd like to give to the insiders. To the outsiders who are not software developers or system engineers, I would like to leave them with this. There is a magical world behind that curtain. Open it up. You'll be amazed at the things you see, and you will be amazed and in awe just as much as you will be in looking at the night sky. Join us in that journey. That's the message I hope to give to both those parties.
And I think that's a fantastic point to end our conversation today. Grady Booch, thank you very much for spending so much time with us today.
You're welcome. This has been the most fun I've had with my clothes on in a long time. Thank you.